Thanks.
All right, so we'll start with a free fall motion. We talked about that one during the lab, and we learned that any object under gravity, the motion of an object under gravity is called a free fall motion. So if we drop an object from a certain height, that object is going to go down with an acceleration, will speed up. So its velocity will not constant, rather its motion will be a constant acceleration motion. And if we throw an object in the upward direction with an initial velocity, then the velocity of the object will decrease at a constant rate over time. So the object will slow down and will have a constant deceleration. After reaching some height, the velocity of the object will be 0, but the acceleration will always be 9.8 meters per second square. And the acceleration due to gravity is always towards the center of the earth or in the downward direction. So free fall motion is a constant acceleration motion. And we already know the value of the acceleration is 9.8 meters per second squared. So one good thing about free fall motion is if we see a problem that we throw an object in the upward direction, then we realize that the object for some time will go up, then stop at the maximum height, and then come down. We may think that, okay, we have to use two kinematics equation, one for upward direction and another for downward direction. But we don't really need to do so. We can use just one kinematics equation for the entire motion to solve some unknown parameter. Because for the entire motion, when the object is going up, coming down, acceleration due to gravity is always downward, and its value is 9.8 meters per second square. So that's why that will help us actually understanding that free fall motion in the whole entire motion is a constant acceleration motion. So we'll see that one with the problem. And whether we're going to use plus 9.8 or minus 9.8 meters per second square, that will depend on the choice of our coordinate axis. So I will start with a problem. And actually I should ground. Okay, so we have a problem that an object is thrown upward with a speed of 20 meters per second from ground. Determine maximum height reached by the object, time to reach maximum height, entire time to come back to the initial position, meaning that to come back to the ground, and the velocity with which it strikes the ground when it comes back. So we'll first do problem number A. We have to find the maximum height. So this is a free fall motion, and we know that acceleration of that motion is 9.8 meters per second squared. So very first thing we need to do is we need to draw the diagram of the problem. So we have an object at the ground position, and we throw the object in the upward direction. So we tell that, okay, the initial velocity of the object v0 in the upward direction. We are asked to find the maximum height reached by the object. So the object reaches there at a point and reaches its maximum height. And we can tell that this position is y. The ground position we can tell y0. And we can also always tell y0 is equal to 0. Final position is y, which is not known to us. This is what we need to solve for. For free fall motion, what's the direction of acceleration?
Downwards.
So I'm gonna draw that direction of acceleration in the downward direction. All right, so one key thing is in part A, when the object reaches its maximum height, what's the velocity at that position? Velocity at the maximum height will be 0.
0.
Okay. Initial velocity is not 0. We have given some speed initially, v0, in the upward direction. So since this is a free fall, since velocity y0, y, which are actually y is a final position, a are vector quantity, those numbers could either be positive or negative. And that entirely depends on our choice of coordinate axis. So suppose I tell upward direction to be positive. This is our coordinate axis. So once we know upward direction is positive, then we can tell, right, v0, how much that will be, plus 20 or minus 20. Which direction? Okay, that is plus 20. A will be plus or minus?
Minus.
Minus.
Okay, y0 is 0. Y is the one that we don't know. T, we don't know. Time to reach the maximum height, we don't know. Okay, so V naught and V, actually we know final velocity is equal to 0. Okay, so now utilizing that one, those given parameters and kinematics equation, we can solve the problem. We can choose V square is equal to V naught squared plus 2a y minus y naught, one of the kinematics equation. So in this case, final velocity is 0. V naught squared is 20 squared, 2 times negative 9.8, and then y minus y naught. Y naught is equal to 0, but anyway, we can just solve for y minus y naught. So the thing I'm gonna do is we're gonna transpose 2 times negative 9.8 times y minus y naught to the left. So it's become 19.6, positive 19.6 y minus y naught, and on the right hand side we have 400. To solve for y minus y naught, we have to divide everything by 19.6. And how much we get?
20.41.
Okay. All right, so we say that the maximum height reached by the object will be 20.4 meters. Okay. Now, why we really used that equation? Again, given the parameters that are known, and we need to solve for y minus y naught, so we have chosen that particular kinematics equation. We did not choose something involved t because we don't know t yet. All right, so just to give you some comparison that what's coordinate axis means and how the problem can be done by using another coordinate axis. For example, I use downward direction to be positive. If I use downward direction to be positive and look at my diagram on the left, I'll try to write everything. So V naught, how much V naught will be?
-20.
And why it is -20? Why?
Down is positive, right? It's down is positive, right?
Downward is positive, and which direction is in initial velocity? Which direction we have drawn it?
Upward.
Upwards.
For that reason, V naught is -20. Okay. All right. So then we write A. What that A will be?
Positive 9.8.
Positive 9.8 meters per second square. Okay. And then y naught is known. Y naught is 0. Y is not known, and t we don't know. So if you solve this one, we're gonna have v squared is equal to v naught square plus 2a y minus y naught. Final velocity is 0, so 0 squared is 0. Initial velocity is -20 whole squared. And this one is 2 times positive 9.8, then y minus y naught. Okay. So I get pause. Is everything okay? Yes, correct. Okay. Something seems not right. Okay, that's fine. All right, then we have negative 19.6 y minus y naught. And then we have 400 here. Negative 20 square gives you positive number. And then we gonna find y minus y naught, which is 400 divided by negative 19.6, and you're gonna get negative 20.4 meters. And now all we have got actually negative 20.4 meters. So the object reached a height of 20.4 meters, but we get negative because we have taken downward direction is positive. So since the object is going in the upward direction to reach the maximum height, that's why we end up getting negative 20.4 meters by the choice of our coordinate axis. Question?
So I guess with the acceleration being positive, wait, how would you know which direction to go? How do you know whether it would be positive or negative? How do you know which one to use?
You can use anyone. There is no problem.
Anyone will be fine.
Anyone you can use because anyone gives us the explanation. So what we get for this place maximum height, 20.4 meters when you use upward direction to be positive coordinate axis. So does it make sense? Is it plus displacement? We see that, yeah, we get plus displacement plus 20.4 meter because we have chosen upward direction to be positive. Do you see that?
Yeah.
But I choose, okay, downward direction to be positive, which means any displacement in the upward direction, we should get a negative number. That's what we get, a negative number when we use that downward direction to be positive. But look here, both values are the same. Okay.
So I guess for the answer for A, you could have even put, I guess, plus or minus 20.4. Like you say, it doesn't matter.
Because minus 24.4, all it means that displacement is in the upward direction because we have chosen downward displacement to be positive. And then based on the coordinate axis, we put, we see that acceleration is plus 9.8, initial velocity is negative 20. And since everything we change, so our final answer will also change. The sign will change, not the number, the magnitude.
Okay.
Good. All right. So now we're gonna do time to reach the maximum height, part B. Okay, time to reach the maximum height. Now, when you do this one, very first thing we do in part A or part B, in each part, that we identify what's the initial position and what's the final position to solve that problem. So they're asking us to time to reach the maximum height. So definitely we will start our time when the ball was thrown. Okay, so we'll draw, okay, the ball is thrown right there, from there, and we'll call that y naught is equal to 0, our initial position. So the final position of the ball is at the top because they're asking time to reach the maximum height. So this will be the final position. Okay, for example, we don't know it, although we just found that will be 20.4 meters. They are asking us what's the time to reach at that point. Okay. We know one thing, at the maximum height, what's the velocity? That is 0. Again, for any free fall motion, acceleration is always down. So I'm going to use upward direction to be positive. This is, again, this is our choice, that which direction of coordinate axis we're going to use. So we know V, final velocity, we know initial velocity is in the upward direction. So I should write that one. Acceleration is known, but we don't know T. One of the kinematics equation that we can use is V is equal to V naught plus AT. So what is V in this equation? Initial or final velocity?
Initial. Final.
Final.
And that is how much? 0.
0.
What's the initial velocity? 20 plus 20, because we are using upward direction to be positive. And what's the acceleration?
Negative
Negative
9.8.
9.8.
Okay. All right, if we use upward direction to be positive, okay. So now we're gonna solve for T. I'm gonna transpose negative 9.8 T to the left. So it becomes positive 9.8 T. And then we have this. And then T can be found dividing by 9.8. Can you please solve that one? How much you get?
2.04.
Okay. So time to reach that maximum height for this object is 2.04 seconds. You can try using your coordinate axis in the downward direction, but in that case, V naught will be negative 20 and A will be plus 9.8. Let's just try that one. It will give you some interesting thing. So suppose I use this as downward is to be positive. So if that's the case, I use the same equation, V is equal to V naught plus AT. Final velocity will be 0, but initial velocity will be how much?
Negative 20.
And acceleration will be?
Positive 9.8.
Okay. So in this case, I can just keep 9.8 T to the right because it is already with a positive sign. I will transpose negative 20 to the left. So it will be 29.8 T. And then I can find T dividing both sides by 9.8. So T will be 20 divided by 9.8. 2.04 seconds. What you notice that when you find time using two different coordinate axes, you must end up with a positive number, no matter if you use plus sign or minus sign. Did you notice that?
Yeah.
But whenever you try to find displacement or velocity or maybe acceleration, then if you use upward direction and two different coordinate axes, you must get same number but with a different sign, because displacement velocities are vector quantities. So if you choose upward direction to be positive and you get a displacement in the upward direction, you should get a positive number. But if you use downward direction to be positive, but your displacement is upward, then you should get in your answer a negative number. But to find time, you must get a positive time, because a negative time does not make any sense. Is that clear to you?
Yes, sir.
Okay. Very, very important discussion. And if you think that way, you will see, I mean, you can always justify your answer. Okay, so you're gonna go to find the entire time for the ball to come back to the initial position. All right, we can do this thing, this one in two different ways. How much time we found to go for the ball to the highest point? We found 2.04. So to find the entire time starting from the ground and coming back to the ground, all we need to do is multiply both sides by, multiply 2.04 by 2. So you're going to get 4.08 seconds. The reason we can multiply is because going up to the highest point, that displacement, and coming from the highest point to the ground, that displacement are the same, and accelerations are the same. While it was going up, it was already had an initial velocity, and it is slowing down with a deceleration of 9.8 meters per second square. But when it reaches at the maximum height, its velocity starts with 0 and then comes down and increases velocity. And that time, that part of the motion, velocity will increase. But in both cases, the magnitude of that velocity, the magnitude of the acceleration is 9.8 meters per second square. And for that reason, if we know how much time it takes for the ball to go up to the highest point, that will be the same time for the ball to come down to the ground where it started from. So that we just need to multiply that time that we found in part B by 2. That's one way. Another way is we can use kinematics equation and try to understand what's the initial position and what's the final position of the ball. In part C, initially the ball is at the ground. Where is the final position of the ball in part C? Where is the ball?
On the ground.
It's on the ground. It's on the same position. So it went all the way up and come down. So right there. So its initial position and final position are the same. What did we learn about the displacement if initial and final positions are the same? What's the displacement of the ball if initial and final positions are the same?
0.
0, because initial position, suppose we tell 0, and if the ball come back to the same point, then that ground position is also 0. So y minus y naught is equal to 0. Displacement of the ball 0. However, distance traveled by the ball is clearly not 0. Okay, but we don't care about knowing that distance while we use kinematics equation, because in the kinematics equation, x naught or y naught, those are not distances, those are positions. Do you understand me? Do you follow me? Okay, so that's very critical part. That's why most of the students confuse. They think that those x and x naught or y naught are distances, but we don't use distances in those kinematics equation. We just use positions in those kinematics equation. So we see initial and final positions are the same. For the entire motion, when it goes up, stops, and comes down, what's the direction of acceleration? Direction of acceleration is always down.
Down.
Okay, And whether we're gonna call that plus or minus, that depends on our coordinate axis. Another thing, when the ball comes back down, okay, so let's just do one thing. The ball was thrown in the upward direction with V naught. When the ball comes back down to the ground, at what velocity you think the ball striking the ground? Will that be a zero velocity? Or it will be more than zero velocity? When it's coming back down, striking the ground, what velocity that will be? Do you understand what I mean? I'm asking that what would be the velocity when it comes back down to the ground?
Would it be 0?
All right. Try to think about that. So when you throw the ball with 20 meters per second initially, what happens when it goes upward? What happens to that velocity when it goes upward?
Slows down.
Would it be 2 times the original velocity? I don't know, but I feel like it'll be multiplied or something.
Okay, let's just make it simple. Okay, I'm asking you that if you you are throwing the object with 20 meters per second, what happens to that object when it starts going up? Will it remain 20 meters per second, or will it decrease as it goes up?
It decreases as it goes down.
Wonderful. When it reaches the maximum height, what's the velocity at the maximum height?
0.
0.
Now it turns back, right? It doesn't hang in there. So when it comes down back, what happens to the velocity of the object?
It increases.
This again.
From 0, again it increases, right? It increases. Then as it is approaching to the ground, is it increasing more and more?
Yes.
Yes. So what you think, will it hit the ground with 0 velocity or with some velocity?
The 20 or
Well, it will definitely not hit the ground with 0 velocity, right? It will hit with some velocity. Suppose we don't know what velocity it's hitting the ground. So you can draw that one. What I'm drawing is, I'm drawing the final velocity of the ball when it is striking the ground by the blue arrow, okay? And I write it V. Why I'm writing V there? Because in our problem, we are asked to find the entire time for the ball when it starts from the ground and comes back to the ground, where initial position is 0, final position is also 0. Initial velocity is in the upward direction and final velocity must be in the downward direction. And that V, for example, we don't know. But one of you have guessed. You gave me a number. How much you told me that you expect?
20.
You expect that will also be 20 meters per second. So you said that we know that the initial velocity with which we throw the ball was 20 meters per second. And when it comes back down to the ground at the same point, that will also be 20 meters per second. All right, so that's our guess. We'll see if that's true. But before that, our goal is to find the entire time. It's not the time only going from the ground to the top. It's the entire time going from the ground to the top and coming back to the ground. That's time we'd like to find. And we expect that that time will be 4.08 seconds. So you're going to use the kinematics equation. Good thing is, for the entire motion, when the ball is going up and coming down, acceleration is down. It's a constant acceleration motion. Going up and coming down, everything can be covered by one equation. So you can write, okay, y minus y naught is equal to v naught t plus half AT squared. But what's the displacement of the object? What did we say? That is
0.
0. Initial and final positions are the same. V naught, suppose we use upward direction to be positive, then V naught will be 20. T we don't know. We are trying to find that entire T. And if we use upward direction to be positive, A must be negative 9.8 T squared. Okay. So what we need to do, we see this one is, I think I'm missing something there, 20T minus 4.9 T squared. So this is a quadratic equation. But this is a simple quadratic equation because the constant term that we see, the third term in this equation is 0. So what we can do, we can factor out T on the right-hand side. So what should be in the parentheses? What should be for the first term?
20 minus 4.90.
Good. So we will have two solutions for this one. One is either T equal to 0, which does not make sense because if we throw the ball in the upward direction, for the ball to travel going up and coming down must not be 0. It should be more than 0. The other solution should be 20 minus 4.9T must be equal to 0. From there, we can solve for T. I can transpose negative 4.9 to the right. So that will become that. And divide everything by 4.9. If you do so, how much you're gonna get?
12.1.
You will get 4.08 seconds. Did you expect that? Okay, so you see that you can solve this way too. I mean, which way you're gonna solve doesn't really matter. Both will be right. But I prefer the lower one because you will realize soon that not always you will be able to multiply by 2 if the ball does not come back to the same height. So suppose we throw an object from the edge of a cliff and the object goes upward and comes back down and goes down further to the base of the cliff. So their initial and final positions are not the same. So if initial and final positions are not the same, then if we find the time to reach the maximum height, then we cannot simply multiply by 2 to find the entire time. In that case, the second way that we have done will help us to solve the problem, to solve the time. Right, last one is we are trying to find, remember that I already asked you the velocity with which it strikes the ground. And you guessed that the velocity with which it strikes the ground probably will be 20 meters per second. So let's do that. So we can use the same diagram that I have drawn there. So V is equal to V naught plus AT, because we are now trying to find the velocity, final velocity. We don't know this one, but we know initial velocity is 20 and A is negative 9.8. If we use, of course, upward to be positive. Let's just do that one. For every equation we use, we should show our coordinate axis. There also I have used upward direction to be positive. Okay, so how much we And T, what was the time we found? 4.08. How much you get? Can you solve that, please?
Negative 19.984.
So we're gonna use negative 20 meters per second. Remember, we expected it to be 20 meters per second. So, but we get a negative sign. It makes sense because if you look the arrow, which direction we have drawn final velocity?
Upwards.
Final velocity.
Down.
Go down.
This velocity downward. Final, we are trying to find velocity downward. And as per our coordinate axis, any downward velocity must be negative. Okay, any downward velocity must be negative 20 meters per second. Okay, so that's why we get a negative number. So give you some examples. So suppose we use downward direction to be positive. And we use the same kinematics equation, V is equal to V naught plus AT. And we would like to find final velocity. So in this case, what is V naught? Plus or minus?
Minus.
And you know why? Because if I tell downward direction to be positive, but our V naught actually initially was in the upward direction. That's why it's minus. How about A? Plus or minus?
Plus.
And T is 4.08. So if you solve that one, you're gonna get V to be 20 meters per second. What's the difference? What's the difference between this and that?
Coordinate axis.
You see that one we get with a negative number, another we have a positive number, but it makes sense. Actually, finally the object was going downward, velocity is down, but we have chosen in the first case upward direction to be positive, so we end up getting a negative velocity, which shows the object was going down. And then in the second case, we get a positive velocity because we already chose downward direction to be positive and written down the parameters according to the downward direction in our kinematics equation. And that's why we get those numbers plus and minus. As I said, if you choose your coordinate axis up or down, you can do that one, but you have to be consistent writing your given parameters plus and minus sign. So once you solve that one using plus or upward or downward direction to be positive, if you solve for velocity, they will just switch the sign. If you solve for displacement, they will switch the sign. But if you solve for time, you must get the positive number because time cannot be negative. Is this clear to you?
I just have a question, I guess, to reiterate. So you're saying if we choose to choose velocity in the upward position, that means we have to stick with it so our signs correlate?
Can you ask me a question again? I'm quite not sure what you wanted to ask, but I'll try to understand what's your confusion or question.
Okay. You said you gave us two cases, one going up and one going down.
Wait,
So
give
you
me, can I stop a little bit? I give you two cases. You said one going up and one going down. There I need to clarify. Nothing is going, those, I mean, this
Okay,
thing.
well, the coordinate axis.
Exactly. I mean, I can
Okay.
tell that. I'm just saying, I'm gonna tell upward direction to be positive. You understand that? Or downward direction to be positive. Okay, so now you say.
Okay. So you gave us two cases, basically saying downward direction positive or upward direction positive. You're saying that if we go with upward direction, that we must stick with it so that all of our values will be either negative, I guess.
Uh, very good. Okay. Can I stop and then I explain from here. So if I use with upward direction to be positive, you see that? Okay. I use a kinematics equation. So if I use upward direction to be positive, what V naught I write? For V naught, what do I write?
The positive 20.
And why? Why I have written positive 20? Why not negative 20?
Because you chose the upward.
Because which direction V naught is? Which direction V naught is? Which direction we are throwing the ball initially?
Sorry, upward.
V naught is upward. Do you see that arrow with an upward? Like this
Yeah.
one? Okay. So look here, V naught. V naught is upward. And our coordinate axis is upward.
Upward. Yeah.
V naught will be positive. Okay.
Positive. Okay.
Okay. Now look, what's the direction of acceleration?
Downward.
What's our coordinate axis?
Negative.
What's our coordinate axis? Which direction coordinate axis is?
Downward.
Coordinate axis is upward.
Oh, down. What?
Upward, right? This one.
Okay, you're breaking up. Sorry, so I'm getting confused.
Okay. So that coordinate axis is upward. Acceleration is downward. So what should acceleration be? Negative 9.8. Okay. You hear me? I think I'm breaking up to you again.
Yeah. Yes. You said acceleration is downward, so it should be, the value should be negative.
Exactly. For
Okay.
free fall, acceleration is always downward. Okay. So anytime you get a free fall, you should always draw that arrow so that you can write whether it's so. You see that when I use upward direction to be positive, I use V naught plus, but acceleration I use minus. But if I use downward direction to be positive, what did I use V naught for? Plus or minus?
Minus?
You see, why minus? Because V naught was upward, but I have chosen downward direction to be positive. So upward velocity must be written with a negative sign. So we have negative. How about acceleration? What did I write for acceleration? Plus or minus? I use?
You use plus.
And why? What's the direction of acceleration? Acceleration is always downward.
Downward.
And I have chosen now downward direction to be positive.
Positive.
So acceleration must be downward if I choose downward direction to be positive. Now, once we do that, I solve that one and I got velocity to be plus 20 meters per second. But in other case, the first case, I got velocity to be minus 20 meters per second. Both values are the same. However, one value is positive, another value is negative. It makes sense because final velocity was downward. Now, since I am taking upward direction to be positive in the first case, final velocity must be negative number, which I got. Since in the second case, I am taking downward direction to be positive and final velocity was actually in the downward direction. So we must get a plus number for the final velocity, which I got in the second case.
I think I understand now.
Okay.
Can I have permission to record, please?
Again, as I said, don't hesitate to ask me question. And can I ask your name, please?
Misha?
Misha. Okay. All right. As I say to all of you, anytime you have any confusion, particularly in this coordinate axis, feel free to ask me. Even if you have confusion after the class, you can always write me email or set an appointment with me. I have given you the a link, Zoom link for my office hour. My office hour is from Tuesday from 2 to 4 and Thursday from 10 to 12. And you will get the Moodle like in office hours, office hour. If you click there, you can find the Zoom link, and that Zoom link is different than the class Zoom link. However, you need to write me an email if you want to meet me in my office hour beforehand. Okay.
Okay, it's still not allowing me.
I didn't allow you. I thought I allowed. Michelle. Misha Smith, right?
Correct.
Yeah, I allowed you. Can you try, or I don't know what's going on? Okay. We're jumping here and there. Yeah, I gave you permission. I mean, try to log in. I mean, I can see that I gave you permission. Okay.
Okay, I'm not sure why I'm still getting the prompt to ask you to give me permission to record.
Do one thing. I will remove from, because I can see only remove permission. Okay, from against your name, which means I already gave you permission. I'm gonna remove and then give you permission back. So do you see anything now?
No, I'm not sure what's happening.
Must be something else then. I don't know about that.
Okay.
Your device or okay. So I'm gonna go back. Do you still see my whiteboard?
Yes.
See. All right. So next thing I'm gonna do is I will copy a problem from the book. And solve that problem. Strange. What? Why the whole thing is moving? Hmm. What? There's something. I hope that's not the same. Should be an option. Just give me a minute. I'm just struggling to move that one. Any idea how to move that? I'm just going to delete that. Copy. Okay, I think I'm just copy somewhere now and we'll solve it, but that's kind of, yeah, I think it's working now. For some reason, it's not working. You see my whiteboard, right? I'm just wondering where everything's gone. I'm just gonna put it again. Where is that going? Okay. Okay, I'll find it later on. Okay, do you see what do you see on the screen now?
A problem from the book.
Okay, problem number 47. That's from chapter 2. Okay, so a stone is thrown vertically upward with a speed of 12 meters per second from the edge of a cliff 70 meters high. How much later does it reach the bottom of the cliff? What's its speed just before hitting? And what total distance did it travel? So we're gonna do one by one, one at a time. In first case, how much later does it reach the bottom of the cliff? So we need to identify which is our initial position and what's the final position. And then once we identify those, we can find the time in between those two positions. So what's the initial position in this case? And what's the final position for the stone? You know that? What's the initial and what's the final position?
The initial will
And
be
it
on
was
the,
zero.
Where is that initial position?
on the cliff.
Okay. And what's the final position?
Ground to the water.
Okay, so I'm gonna draw that one. It's important that we exactly know the initial and final position, because you're gonna use kinematics equation for that initial and final. So right there is initial position, why not? And final position is right at the ground. Okay. And we are trying to find the time for those two positions. Note that you may be confused. Does it mean we are just trying to find from the cliff to the ground while the object is coming down? It's not actually. You are trying to find the time when the ball is thrown, the stone was thrown upward. So you're gonna find the time, entire time, starting from the cliff, going up and coming down. But we really don't need to know the distances that it is traveling in the upward direction and all of the distances. All we need, okay, what's the initial position and what's the final position? And which direction initially the ball, the stone was thrown. So what's the direction, which direction initially the stone was thrown?
Upward.
Okay, so that matters. Okay, this stone was thrown in the upward direction. That velocity direction matters to include the entire time. Okay, we know what's the direction of free fall? Acceleration, direction of acceleration for a free fall?
Downwards.
Downward.
Downward.
For the entire motion, it is downward. Okay, and we are trying to find what's the entire time it takes to come back down to the ground. Okay, that time. Do we know the final velocity at the ground? Is it 0 or it's other than 0?
It's other than 0.
It's not 0. Very good. It is other than 0. And we don't know actually if it is, how much it is. We even cannot guess at that point. It cannot be 12 meters per second. Okay, it cannot be this one because it was 12 meters per second at the top of the cliff. Then when it's coming back down and reaches at the same level, then probably, then it will be 12 meters per second, but it's gonna go even further down and striking the ground. So it will definitely strike the ground with way more than 12 meters per second. Okay, so if I tell y not equal to 0, what is y? Do you know that? Any other information given in the problem? Any other number you see in the problem?
Displacement.
The height. and the-
Gravity.
It is given. So if so remember, positions are vector quantity. To tell y, we need to know our coordinate axis. So if I tell upward direction to be positive, if I tell upward direction to be positive, then let's start writing all the numbers that we know. The easiest probably y naught, of course, y naught equal to 0. Okay, v naught is how much? Plus or minus?
Plus.
Plus
What should be acceleration?
Negative 9.8.
Okay. T, we don't know. What's y? Do we know that?
Would that be 70?
Okay. And note again, y is position, right? So it's not plus 70 or minus 70.
Minus.
Okay. Which direction we have taken positive in our coordinate axis?
Upwards.
Upward. What's the displacement of the object? Downward or upward?
Downward.
Downward.
They both.
Downward, because initially the ball was at the cliff, finally the ball is at the ground. So what's the direction of displacement? Downward. So if downward direction is the displacement, but we have taken upward direction to be positive, what should be the final position? Negative 70 meters. Okay, that's crucial. we are not given that negative number in the problem, but we have to write down that one, otherwise the problem will be wrong. Why is that again? Let's just see. That's the height. This one is how much? 70 meters. So we know that the difference in position must be 70 meters. If I tell y not equal to 0, y must be negative 70. So that way, let's just see y minus y naught, what it gives us. If y is negative 70, y not equal to 0, how much you're gonna get? Displacement is negative 70 meters. Does it make sense with our coordinate axis? What's the direction of the displacement we see for the ball?
Downward.
Downward.
Downward. But our coordinate axis is
Upward.
Upwards.
that's why we get our final value, final position is negative 70. Okay, so now V, with which it strikes the ground, we don't know. But we expect that if we take upward direction to be positive, the final velocity should come out to be negative. Now we would like to find which kinematics equation we can use to solve the problem. Okay, so we can use y minus y naught is equal to v naught t plus half at squared. Y is known. Now this one is a quadratic equation, but not that simple as we have done last time, because it doesn't have a 0 in the third part. It has some integer number, some numbers other than 0. So what we need to do, I'm gonna bring all the terms to the left. And put 0 to the right. So it has the form of a quadratic equation, similar form as ax squared plus bx plus c equal to 0. And if that's the case, then the solution of that equation is x minus b plus minus b square minus 4ac divided by square root of b square minus 4ac divided by 2a. Okay, so you have to compare the quadratic equation, general form of the quadratic equation, to our quadratic equation, where a will be 4.9, b will be negative 12, and c will be negative 70. So we can write a is 4.9, b is negative 12, and c is negative 70. So if you plug those numbers, we can solve for time. It will be minus 12 plus minus b squared, which will be negative 12 squared, minus 4 a c whole square root, and then you have 2a. So if you solve that one, then we can get 12 plus minus. You can try giving me the number in the square root. Minus 12 square will give you a plus number.
144.
144. And then there is negative 4 times 4.9 times negative 70. That will also give a positive number. So if you add everything, you're gonna get 1516. Is that right? 1516 in the square root. Okay. And then if you take the square root,
That's 38.9358 and some other number.
you said if you take the square root 1516, how much you get?
38.58.
Okay. 1516 square root.
Sorry, 38.9358.
38.9. Yeah, let's just use plus minus 38.9 divided by 9.8. We have to take the plus because otherwise you're going to end up getting a minus for time. But plus will be the one. So plus 38.9 plus 12. Will be 50.9 divided by 9.8.
That's 5.19.
We can use 5.2. Okay, so you're gonna get t. So let's use that one. T is 5.2 seconds. So we found the entire time for the ball to reach the ground, which is 5.2 seconds. Okay. Just to give you some idea about, again, the coordinate axis. If I use, I'm not going to do it completely, but if I use downward direction to be positive, how those numbers would change? Y naught will be 0. What V naught will be?
-12.
A.
Positive 9.8.
Y.
Positive 70.
And V, we don't
We don't know that.
know it. So now you can just set up the problem like that. Okay, Y minus Y naught is equal to V naught T plus half AT squared. Same equation you need to use. However, Y will be 70, Y naught will be 0, V naught will be negative 12T, and that will be 9.8 T squared. So you can transpose everything to the right in this case. So left hand side will be 0, right hand side will be 4.9 T squared, negative 12 T, negative 70. So if you compare this equation with this equation, what do you notice?
It's the same thing.
It's the same thing we expected, because for time, we expect the same time, okay, with no positive or negative thing. So for that reason, no matter which coordinate axis you use, while you are calculating time, you should end up with getting the same number of time, and that's why the form of the equation is the same. All right, so now let's see. In part B, what's the speed just before it hitting? Which means we are trying to solve for V. We're trying to solve for this one. Okay, we're gonna solve. So in part B, we can use V is equal to V naught plus 80. V naught we know, if I take upward direction to be positive, V naught will be 12. And A will be negative 9.8. And T is 5.2. You can solve it, how much you get. 12 minus 9.8 times 5.2. How much you get?
Negative 38.96.
Okay, negative 38 point, or it's almost negative 39 actually. Let's just use negative 39 meters per second. We expected it to be negative because final velocity is in the downward direction, but we have chosen upward direction to be positive. So it's always best to quickly write the coordinate axis right there, that I'm using upward direction to be positive. All right.
So
Then-
I have a question, Dr. Freer. When it comes to us doing these assignments that we have to submit, do we always have to put the direction of the coordinates on our working page or
Yes.
notes page?
What usually I ask, the way I ask for the quizzes and the structured questions in the test, I ask you that use rightward direction as your coordinate, I mean upward direction for your coordinate axis. Okay, which means you just have to draw. I mean, I will also ask you, draw your coordinate axis and then use kinematics equation. Okay, so you have to show that one. So in part A, I ask you take upward direction to be positive. In part B, I can ask you take downward direction to be positive, and you have to stick, I mean, you have to follow that instruction. Is this clear? Okay.
Yeah.
If in case I don't ask you, just I ask you find the time or find the velocity there, that's your choice which direction you're gonna use your coordinate axis. So it's always best practice in this case, draw your coordinate axis and do the problem.
Okay then.
Then we have to find part C, the total distance did it travel. First thing we know that we found the height of the cliff. We know that the stone was going up, so it's traveling a distance while it is going in the upward direction. Then it's coming back to the same position from on the cliff. So it's also traveling that much distance, and then it's traveling 70 meters more while it is going in the downward direction. So to find that one, the total distance did it travel, we first need to know how much maximum height it reached after it is thrown in the upward direction. So in part C, first we'd like to find that maximum height reached by the stone. To do so, I can use V square equal to V naught square plus 2ay minus y naught. Okay. I can use that one because I'm looking for the maximum height. Note that in this case, the diagram is not the same in part A. In this case, we have, let's just draw it. We have this cliff. We don't care about the bottom of the cliff. This is the top of the cliff and the final position is right there. That's Y and that's Y naught. Do you understand that? Clear?
Could you go over that, please?
Do you want me to repeat?
Yes, please.
Okay, so I'm gonna basically, I want to delete everything at this point. And I also want to delete this one. First, I would like to find the max height. The stone reached, okay, max height, the stone reached. I will draw the diagram. That's the top of the cliff. Okay, so when it reaches the maximum height, where is the position of the stone? Top or lower than the initial position?
Lower than the initial position.
Top, right? That's the maximum height. Start from the top of the cliff, and that will be the
maximum height?
yes,
Right.
that will be the maximum. So what happens at the maximum height? What happens to the velocity of the object at the maximum height?
It starts to decrease.
0.
Is that right? When it reaches the maximum height, its velocity becomes 0. We are already given its initial velocity. Do you see the diagram difference? In the first part, when we are trying to solve for the entire time, its initial position is at the top. But where is the final position in the first part?
At the bottom?
At the bottom of the cliff. Okay, at the bottom of the cliff. What I am really doing that is interesting. This kind of thing very interesting sometimes. Okay. Like that. I want to change. Okay. But in this problem, when we try to find the max height, the initial position is at the top of the cliff, and the final position is above that top. And above that top, we call it y, final position, and at the final position, final velocity is equal to 0. Okay, so we got to be careful right there. For part A, the final velocity was not 0. We found it to be negative 39 meters per second. Okay. A is always down, and we don't know how much time it took to reach the final height. So since we don't know time, we're going to use v square is equal to v naught square plus 2a y minus y naught. Now we know final velocity. Is this clear to you that for doing, solve this problem, we know final velocity, and how much is that?
0.
0. Initial velocity is 12. I haven't used coordinate axis yet, but again, as I said, it's always best practice to show the coordinate axis right there, so that I know initial velocity is plus 12 squared, and this one is 2 times negative 9.8, and we are looking for y minus y naught, the maximum height actually. So then we have 19.6, positive 19.6, y minus y naught, and then we have 144, and then y minus y naught is equal to 144 divided by 19.6. How much you get?
7.3.
7.3 meters. Okay. Note that we are asked to find the total distance traveled by the stone. So 7.3 meter is from the top of the cliff in the upward direction to the maximum height.
Dr. Kibera, sorry, I just have a question. Okay, so when we're doing this coordinates, right? Based on what I'm seeing, the final velocity is basically always where the final position is, and the initial velocity is always where the initial position is?
Wonderful, very good. Final velocity is always at the final position. Initial velocity is always at the initial position. Wonderful. Yes.
Thank you, because I was confused, but I got it now. I got it.
Very good. And thank you for asking that question. It's going to help all others also. So we found the 7.3 meter is the distance from the top to the maximum height. Is that clear to you? Okay.
Yes.
Yes.
Then the stone is coming back, and then it will come back to the same top of the cliff. So it will travel another 7.3, but then is going to go down by 70 meters to reach the ground. So the total distance traveled by the stone will be how much? 7.3 plus 7.3 plus 70 meters, and distance are always a positive quantity. So you can find that one. It will be 84.6 meters. Total distance, okay? Any question? Do you have any question to ask?
I have a question.
Yes.
So the maximum height the velocity of the maximum height I see is 0.
Yes.
Is it always that in every equation or in just this specific one right now?
For any problem, free fall problem, any free fall problem, if you throw an object in the upward direction, when that object reaches the maximum height, at that maximum height, velocity must be equal to 0.
Okay.
Did I answer your question?
Yes, sir, you did. Thank you.
I
Okay.
have a question.
Oh,
The last-
give me a moment, please. I'm just going to extend one more line. So if I ask you a free fall question that an object is thrown with some velocity in the upward direction, and I ask you find the maximum height reached by the object, you for sure know at the maximum height, final velocity of the object is equal to
0.
0.
Is this clear?
Yes, sir.
All right, that's it. Okay, so someone wanted to ask me some question.
I wanted to know whether this equation, equation came from that you did last, 7.3 plus 7.3 plus 70.
Okay, and that one you're talking about is this one. How it came from?
Yes, how did you get that?
First of all, this is not an equation. I'm adding some number. Okay, but how do I get that? Okay, let's just elaborate that one a little bit. So I'm drawing it. You see my drawing?
Yes.
Okay. That's crazy right there. Okay, nice. Oh. Just so I had everything there and then really, where is that gone? Anyway, I'm just going to draw somewhere. So that's the object starts from, and it reaches the maximum height. Okay, how much we solve for that y equal to y equal to? We get 7.3 meters. Do you understand that?
Yes.
So it goes there by 7.3 meter, but then the stone comes back down. That is another 7.3 meter. Then the height of the cliff is 70 meters. So the total distance, basically, I can follow like that. So it goes like that, 7.3 meter, another 7.3 meter. Is that clear?
Yes.
70 meter all the way down. So 7.3 plus 7.3, 70 meters. And then from there, it's 70 meters. Is this clear? That's how we did.
It's clear.
Okay, so I don't know why everything that's crazy. Okay. Okay, so I think I wanted to show you everything that that was scheduled. So I will end our session today. I wanted to say that I will give you a quiz on Wednesday at the beginning of the class. All the instructions will be given in Moodle, that's what you need to do. So that will be based on the practice questions and the problems that you have done during the lecture class. So you should really go over the whiteboard notes and the practice problem that I have already posted it in Moodle. So you should really practice on that one. I'll ask you just one questions. So you will have access to that questions at 6 o'clock. And then I will give you some time to write your answer and post your picture of your answer in Moodle. Okay. Again, you have to keep your integrity. You should be honest and should not contact each other for writing your answer, or should not ask someone, some tutor, to write your answer. I don't really look for the final answer. Rather, I look the way you solve the problem. So if you attend my Zoom session, I wanted to see that, did you really attend the Zoom session and did you really deliver the concepts that I have given you, I have shown you in writing those answers. So it's easy for me to see that one. But if I see something different, then I realize something is going on. So you should be, it should not worry about your final answer, rather, like I will ask you, use your coordinate axis. So you have to use your coordinate axis. Depending on your coordinate axis, I'll see, could you really assign the values of plus or minus to the parameters? And then did you draw the diagram and then utilize the equation, kinematics equation, and substitute the values and solve the problem? So I'd like to see the method, the way you solve the problem rather than your final answer. And just by attempting, even if you do your problem wrong, but you start with the right concept, you wanted to show all those things that I want, I will give you in the instruction, you will give most of the point, you will get most of the credits. Okay. Is this clear to you?
How much is Word though?
Well, I'm sorry.
How much is this quiz worth?
Oh, how much is this quiz worth? I don't know yet how much. There will be several quizzes, okay? But most likely the quiz will worth 2% of the overall grade. 2 to 3%. I haven't decided, but it will worth some 2% or 3%. Okay, I try to give 6 quizzes throughout the semester. So that will be 5 or 6 quizzes. I mean, if it's 6 quizzes, then it will be 2.5% of the overall grade.
Okay, one more question. How many tests or exams will be held during the class?
I try to give 3 tests, in-class tests, throughout the semester, and the final exam is different than this one. So 3 in-class test will be 30% of your overall grade, and 5 to 6 quizzes will be 15% of your overall grade, and final exam is comprehensive, which is 35%, and lab is 20%.
Okay, it's powerful.
It is what I wanted to say, that it's very important that you attend the Zoom classes, you keep up with the lectures. It will not be tough, as I said again and again. If you think you try to like cheat or copy, then of course it will be tough for you, because I'm gonna ask you, if I see any problem, I see extraordinary nice answer and doesn't match with my instruction at all, then I'm definitely gonna ask you orally, like explain me and how you get that answer. So rather you keep it simple and don't worry about your final answer. You're gonna get a lot of points on that one. And if you show me that, okay, this is what you understood, and then just for your attempt, you're gonna get a lot of points.
I like that. Thank you.
All right, then. I think I'll stop our session today. If there is any questions, just feel free to email me and set up an appointment for the office hour, okay?
Okay, thank you.
All right.
One more thing. Did you check your email?